Hi guys, welcome back on my channel. So in this video I will cover Laplace transforms. So now Laplace transform is used in solving differential equation with boundary conditions. So whenever boundary conditions are given in the differential equation, then we can solve that particular differential equation using Laplace transforms. Next is it converts differential equation into an algebraic equation. So now let this ft be any function. So if we will use Laplace transform on this ft function, then it will be converted into an algebraic function fs, where s is any parameter. And if we will use inverse Laplace transform on this fs, then it will convert back into normal function. So like Laplace transform and inverse Laplace transform are opposite to each other. Now comes this particular formula. So this is the standard formula of Laplace transforms. So you need to remember this formula. Laplace transform of ft is equal to integral of 0 to infinite e raised to power minus st into ft dt equal to fs. So exact use of this formula I will tell you after some time in this video only. Let's now see the condition for existence of Laplace transform. So now Laplace transform would exist only if limit of ft into e raised to power minus st, this this uh, when the value of t approaches to infinity, then that value should be either finite or zero. If it is finite or zero, then only the Laplace transform will exist. I will tell you one example so that will become clear. Okay, now this is an example. Wait, let me take out the pen. Yes. So now this example is any function is given which is t square. So now ft into e raised to power st. I'll write this thing. What is ft? T square. It is given in the question. Into e raised to power minus st, and t approaches to infinite. So I can write this as t square upon e raised to power st, right? So now what? So now I'll write it here. Wait. Yes. So I'm proceeding from here. Okay. So now you can observe that this is in the form of infinity over infinity, right? So now what is this? We can use L'Hopital rule for this. So now how to apply differentiating numerator and denominator both? So it will be 2t upon e raised to power st into s, and limit is same only, limit t approaches to infinity. So now again this is in the form of infinite upon infinite, right? So now again differentiating up and down. So if I will differentiate it, it will become 2, and it will become e raised to power st into s square. Okay, and I'll write the limit here again. Now you can put the limit. Now put the limit infinite here. 2 upon e raised to power infinite into s square. So e raised to power s square, yeah. So this will give 0. Hence our conclusion is that limit exists. So this is our conclusion. In case it would have been infinite, then our limit would not exist. So now I'll tell one more example related to does not exist. This thing will then become clear in your mind. I'll write. You can take the example of e raised to power t square, right? Ft equal to e raised to power t square. Now solving this. Now how to check? Write this e raised to power minus st as such and write this function as such into e raised to power t square, right? Where limit t approaches to infinite. Now you can use indices rule and you can add them. So what this will become? This will become t square minus st, right? And limit is again t to infinite. So now if you will substitute the limit, then this will become e raised to power infinite, and e raised to power infinite means infinite only. So now this, in this case, your limit is not defined. So what does this mean? That your Laplace transform does not exist, DNE does not exist, right? So this is how you will check this thing, that your Laplace transform will exist or not. So I hope this thing is clear to you. So now let's proceed. We will solve couple of questions now. So let me remove this. Yes, now after removing this, I will write down the question and you can make your notes also simultaneously. Okay, so now the first question is ft is equal to a. Okay, we will start from the basic, where t is greater than equal to 0. Okay, now we will find the Laplace transform of this. So yes, Laplace transform of f of t, right? So this will be integral from 0 to infinite. That standard formula which I have told you. This is this particular formula, right? So this thing only I am using here. So now what this will become? This will become e raised to power minus st as such we will write into function. What is the function? A into dt. I hope this thing is clear. Directly I have substituted the values in the standard formula. So now a integral of this, that would mean e raised to power minus st upon differentiation of this part. This is minus s, okay? And your limits are 0 to infinite. Yes, now you can substitute your limits. So this will become a upon minus s into e raised to power minus infinite minus e raised to power 0. So this will become a upon minus s 0 minus 1, because e raised to power minus infinity would be 0 and e raised to power 0 is 1. So this will become a by s. Hence Laplace transform of a is equal to a by s. Okay, I'll put it in a box. Yes, so this was your first question. Okay, now we will take second question. I'll write down the question. Wait. Yes. Now, question number 2. E raised to power 80. So your function is e raised to power 80. Okay. So let's proceed with white color. So using the formula again, Laplace transform of f of t. I write down the formula first so that you don't get confused. E raised to power minus infinity, e raised to power minus s of t into f of t dt. Okay, now putting the values again, 0 to infinite e raised to power minus st into e raised to power at dt. Okay, now again using indices, this will become e raised to power t common a minus s. Okay, this might be clear to you. Now integrating, so now integrating this t a minus s as such upon differentiation of this part. So we are differentiating with respect to t, hence a minus s is constant and this will come here. Okay, I'll remove this, and your limits are again 0 to infinite. So now substituting the limits, 1 upon a minus s, let me write it with white color only. Yeah, 1 upon a minus s, this will become e raised to power minus infinite minus e raised to power 0, and this will become 1 upon a minus s into 0 minus 1. So minus 1 upon a minus s. So this will become 1 upon s minus a, right? So this was the solution for this part. I'll write it here. Laplace transform of e raised to power at is equal to 1 upon s minus a. This is your second result. So in similar way, if in the question he could have given e raised to power minus 80, suppose he could have given this. So now similarly, now instead of a it would be minus a everywhere. So what this formula will become, this formula will then become uh, Laplace transform of e raised to power minus 80 would be 1 upon s plus a, because instead of this a we will have minus a, right? Then it will become s minus of minus a, this will become s plus a, right? Okay, so wait, s minus a, and this is s plus a, and I'll highlight it here. So these are your results for second question. I'll remove this minus so that you don't get confused. It's not getting removed. I'll cut it here. Yes. So it is e raised to power 80. So you can note this down, right? Okay. Now third question. I'll write down the question, or I'll directly give you the formulas only. No need for derivations, because in GATE you need direct results only. So I'm writing the formula. So your next formula is a Laplace transform of cos 80, cosine 80. So this is s upon s square plus a square. Laplace transform of cos 80 is equal to s upon s square plus a square, right? And then Laplace transform of sine 80, it is equal to a upon similar s square plus a square. So you keep in mind that whenever this s would be here, like I'm telling the difference between the formula of sine and cos, whenever s would be there, then s will not be here, right? Then the constant value, I mean the a will be here. And whenever C will be here, then S will be here. So both the things you cannot remember, so you just remember that whenever S would be here, then S would not come here else. And in denominator, s square plus a square is in both the formulas. So I'm telling this way to remember, right? So you can note this formula, which is this. I'll mark the formulas, just a minute. Yes, so this was your first formula, this is your second, third, fourth, fifth. Now coming towards other formulas. So you just write this as note only, because it's not as such for formula. Yes, uh, Laplace transform of any constant k times any constant ft is equal to this also k times Laplace transform of f of t. If we are multiplying this function by any constant k, then Laplace transform of this whole part would be k times the Laplace transform of f of t only, right? Okay, now second is Laplace transform of f of t plus minus another function which is g will be equal to Laplace transform of f of t plus minus Laplace transform of g of t, right? Now I will proceed with these formulas only. uh, sixth formula sixth formula What is sixth formula? It's for hyperbolic. So Laplace transform of cos hyperbolic at is equal to s upon s square minus a square, right? Next comes seventh formula, which is for hyperbolic sine. So you might predict it right. Wait, I'll write in yellow color only. Yes, sine hyperbolic at is equal to a upon s square minus a square. So you can observe from here that in case of normal trigonometric, it in denominator plus is there, here also, right? But in case of hyperbolic, we are putting here minus, this minus, and here also minus. So these were the Laplace transforms of trigonometric functions. Then I will tell about eighth one is about t raised to power n. Laplace transform of t raised to power n is equal to factorial upon n plus 1 s raised to power n plus 1 is equal to n factorial upon s raised to power n plus 1. So this thing you might have studied in your gamma function. I'll write it here in your gamma function, that factorial of n plus 1 is equal to n into factorial n is equal to this. And this also in gamma function you might have studied, under root of pi, right? So these formulas, or I mean these relationships also, you need to remember. So now I will write of simple algebraic functions. Okay, so now Laplace transform of t is equal to 1 upon s raised to power 1 plus 1. This will come out to be 1 upon s square. From where did it come? I use this formula only, right? This particular 8th formula only. T raised to power n. What is the value of n here? 1 only. 1, right? So now see this 1 and substitute 1 here. 1 factorial upon s raised to power n plus 1. What is n? Again 1. 1 plus 1. It is 1 upon s square, right? So from this formula only this got derived, or I got the result. Next is one more example, 2 example more I'll tell for t cube. So now this will be n is 3, so this will be 3 upon s raised to power n plus 1, 3 plus 1. So what is 3 factorial? 6. 3 into 2 into 1, right? So s raised to power 4 is equal to 6 upon s raised to power 4, right? Now in case if we are having Laplace transform of 1, so in this case now this is 1, so that means that any number has raised, like suppose x is any number, x has a power of 0, then only we will get 1 here, right? So value of our n would be 0, right? So hence it will be 0 factorial, right? And it is now in denominator it is n plus 1, so n is 0, so 0 plus 1. 0 factorial is 1, 0 plus 1 is 1, so this will give 1. Yes, yes. So now for I'll take one more example, t raised to power 1 by 2, right? In this case we will use these relations, we will need to use, right? So now what is n? N is 1 by 2, right? 1 by 2 plus 1. I'm using this formula now, right? 1 by 2 plus 1 upon s raised to power 1 upon 2 plus 1. So ये क्या बन जाएगा? This will become 3 by 2 and this will become s raised to power 3 by 2 also. So now I can write it as this using this formula now. N plus 1 equal to n into, so now I can write it as 1 by 2 1 upon 2 upon s raised to power 3 by 2, right? So now this is root of pi. So now again wait, I will take this in denominator only. I'm writing root of pi, right? And writing this 1 by 2 down here, right? And it will be s raised to power 3 by 2. So this will become root of pi upon 2 into s raised to power 3 by 2. So this was the solution for this type of questions. So that's why I told that you need to use the relations of gamma function here. So you can pause the video and you can note this down. Okay, now I will tell you very important property which is famously known as first shifting property, and very important concept as well, first shifting property. All right, so in case of this Laplace transform, this property is very important and will be used in majority of the questions. So now what is this? Laplace transform of any function f of t let me reduce the pointer size. Yes, now it's fine. Is equal to f of s, right? And if the function is multiplied by any exponent, like suppose anything e raised to power s, as, suppose it is Laplace transform of e raised to power at, suppose, right, into f of t, then this will be f of s minus a. So it will be offsetted with by an amount a only, this, because here I am multiplying with any factor a, right? Hence this will be offsetted by a. Okay, so this is, so that you just remember one thing, that in this case s is replaced by s minus a. So now I will tell you one question, one not one, three, four questions. This will become crystal clear in your mind. So first question. So now if we are having Laplace transform of e raised to power 2t into sine 3t, right? So now what to do? So now in case if I would not have this thing, suppose you just think that this thing is absent, right? This question is this much only, right? So in this case I can directly use the formula in this particular case, right? But in the present question I am having this also, right? So now what to do? So now we need to use first shifting property in this case, right? So how to use? So first step is same, that use that formula only of sine, right? So this is Laplace transform of sine of 3t. So this is, what is the formula? A upon s square plus a square, right? This is the formula. So now write the value. So what is a? 3 upon s square plus 3 square, right? So this will become 3 upon, now what I have told you here, that whenever you are using shifting property, then replace s by s minus a, right? So what is the value of a? It is 3. So replace s by s minus a. So now replacing this, I'll highlight it with other color. Wait just a second. Yes, so this thing will become clear. S minus a, right? And write square as such plus 3 square. So your shifting property has been applied. So this is your final answer. तो इसमें कोई बड़ी बात नहीं है. You just need to replace only e raised to power 2t into sine of 3t. So this is your final answer, right? सो फर्स्ट शिफ्टिंग प्रॉपर्टी में खाली इतना ही है. मैं आपको 2-3 क्वेश्चंस और कराता हूँ ताकि किसी के दिमाग में कोई डाउट ना रहे, राइट? तो अगला क्वेश्चन मैं लिखता हूँ ये. सेकेंड क्वेश्चन इज दिस. Laplace transform of e raised to power minus 3t into cos of 5t. ठीक है, अब कैसे करना है इसे? अब मैंने क्या कहा था, पहले नॉर्मल कॉस का फॉर्मूला ही लगा दो. कॉस के फॉर्मूले में क्या था? ऊपर आपका s आता था और नीचे एस स्क्वेयर प्लस ए स्क्वेयर, राइट? एस अपॉन एस स्क्वेयर प्लस ए स्क्वेयर, राइट? अब क्या है, मैं यहाँ पे लिख देता हूँ कॉस 5t इज इक्वल टू, अब s क्या है, इसको s तो ऐसे ही है, इसको डायरेक्ट ऐसा लिखो, ठीक है? अपॉन एस स्क्वेयर और a की वैल्यू क्या है? 5, तो इट विल बी एस स्क्वेयर प्लस 5 स्क्वेयर, राइट? सो नाउ यूजिंग शिफ्टिंग प्रॉपर्टी, e raised to power minus 3t into cos of 5t. So now using shifting property, now what you need to do, replace s by s minus a, right? So now replacing this, s plus 3 it will become, because it's upon s plus 3 whole square plus 5 square, right? So this will be your answer. Okay, now let's move to the third question. So this is your third question. So let's proceed with this. So now in this case, you have a algebraic function which is, oh sorry, t raised to power 5, right? So Laplace transform first we will find for t raised to power 5, that will be 5 upon s raised to power n plus 1, which is 6. 5 factorial upon s raised to power 6, right? So now we will shift it, I mean we will use shifting property. So using shifting property, so now Laplace transform of e raised to power 2t into t raised to power 5. Now to shift it, we are shifting it by 2 because it is 2t, right? So put s minus 2, which is equal to 5 factorial upon s minus 2 whole raised to power 6. So 5 factorial is 120, 120 upon s minus 2 raised to power 6. So this is your final answer. So this is very easy, directly you can do it. So now next thing, it is change of scale, right? So now for this I will write uh, Laplace transform of f of t is f of s, right? Then Laplace transform of f of at would be 1 upon modulus of a into f of s by a, right? So I'll put it in a box. Okay, so this is known as change of scale. So actually we are multiplying this particular uh, t with any constant a, right? So then this constant will come out in denominator, in the form of mod, and it will be f times f function of s by a, right? So one question I will tell you, this thing will become crystal clear in your mind after this. Okay, so now question is Laplace transform of f of root t is equal to f of s, right? अगर इसका फंक्शन ये है, मतलब इसका लाप्लास ट्रांसफॉर्म ये है, देन लाप्लास ट्रांसफॉर्म ऑफ f of 3 root t, 3 root t. So now they have multiplied this 3 here, right? Similarly means that 3 is any constant, right? So now I'll tell you how to do this. Yellow white be fine. Okay, so now what was the formula was this 1 by a modulus into f of s by a. So you can directly write what is a here, 3. So mod of this into f of s by 9. So this will be your final answer. So this is your change of scale, right? So in the next video we will see multiplication by t and division by t. So this was for today's video. In the next video I will teach you division and multiplication, and then we will proceed towards differential equation, like solving differential equation using Laplace transform. So if you like my video, then you can subscribe to my channel and like and share the video. So thank you.